Um, okay, welcome to SC 561 machine learning module, and let me brief on the aim and also the learning outcomes of this module. So the idea of this particular module will be as we want to have a strong basis in machine learning algorithms, since that is applicable for everywhere nowadays. So I think it will be helpful for even in your final thesis work, those who are, taking thesis work. So idea is in this module will provide you the necessary knowledge and the practical skills in machine learning uh, to solve various different problems available right now. I think it's a high time that there's an AI boom within the world, which is many people want to build system which is coming. Many of the algorithms actually coming from machine learning area, which is I think very important and helpful. So mainly I'm going to focus on supervised learning, which is what we call the classification systems, which is one of the prime thing in AI. If you take the substantial part of AI will be coming from supervised learning. Then we will also have, unsupervised learning. So that means we can learn to understand or similar groupings in data. So those are the two main tasks that I'm going to, focus on when it comes to, algorithm level. Of course, then we will also discuss the other things like associations. What you mean is instead of, you do predictions or groupings, we can also look at, associations among data. So those are the like main types of algorithms that we are going to handle within the module. But of course, we will also learn how to build system from scratch, from start to end, the whole machine learning pipeline. So while doing so, we will also talk about how you handle various different features or attributes under the feature engineering part, developing various models and how to evaluate those models, which means how you may, uh, how you may evaluate their performance in new data, right? And that's the main part of it. And then ethical consideration, because nowadays there's a serious concern about how people use the data, because data is recorded everywhere currently. Also, like we communicate through a Zoom, but nowadays everything can be recorded, can be extracted, they can use to build systems. And there are some ethical considerations, the fair use of technologies. So the technologies can be used to learn a lot of personal stuff. So that will be a threat to our privacy as well. Right now, for example, since we interact all the time in the internet, for example, if you take companies like Google, may know a substantial part of your day-to-day life, right? Which is inevitable, and fair use is very important. That means the data will not go into another third party and they will use for intended purpose, which again will focus in this subject. So we will focus on the core concepts starting from supervised and unsupervised learning, feature engineering, model evaluation, ethical considerations in machine learning. And as students who participate in this one, you will get hands-on experience applying machine learning, because I will be, using machine, Python, as well as various different frameworks in machine learning, scikit-learn, PyTorch, and so on. So all these latest frameworks available for you to build systems. So we'll start with toy problems, and then gradually we will work through real world data sets, right? So that's the plan. And as a part of the assessment, also you will work on various different types of data, right? Going back to what you might be able to do once you complete this module successfully, you need to understand all the key concepts in machine learning. always you should also be able to understand how you may actually extract features or identify features for various different applications. Implementation as well as evaluating various different machine learning algorithms, both in supervised and unsupervised, learning techniques. And then there are various ways that you can evaluate your models. That also one of the things that you have to master. So which one you are going to use, for example, whether you are going to use classification accuracy, precision, recall, F1 measure, or area under the curve, and so on. There are various ways of evaluating, various different machine learning algorithms. So you have to have a good understanding which one to use for a given problem. Then sixth ILO is very, very important. I told you ethical use of the data, fairness, the biases, very, very important. So for example, nowadays people quite a lot of us using systems like ChatGPT or a DeepSeek. Whatever those applications were built on huge amount of data, whether they are biased towards, whether there's any bias, whether they are, fairly use of existing data. So which is something that we have to, think about the learn. And when we also build similar systems, you have to, take care of these issues. Right. I think the final one is the very important one, which I will try my best to give you or expose you to develop or solutions for a real world, problems. You select some practical problem and how you may, provide a solution using machine learning. So that's what we plan. Right. So that's about the aim and objectives. So any questions or anything that you want to clarify before we move? All right, then we'll move on. These are like briefly the content that I'm going to plan to cover. So today I'm going to focus on the introduction part, the input to machine learning algorithms, and then in coming sessions we talk about the supervised learning, which is classification, the clustering, and then how do you evaluate them. Basically we will discuss starting from basic models like decision trees, nearest neighbors, naive Bayes, support vector machines, and then we can go and talk about the random forests and so on. So those are like some of the things that we will discuss under supervised learning. In unsupervised learning, we will talk about K-means, hierarchical, DB-scan. So again, important or key unsupervised learning algorithms. Under the association, I will also talk about a priori. So those are the key algorithms I was planning. And then we will talk about the evaluation and then the data transformation. Under the data transformation, we discuss how do you handle like, data quality issues, imputations, which means like if the data is missing, how do you replace the data? Then dimension reduction, which means when you have a very large data set, especially when you have large number of attributes, how do you remove or reduce it to a more manageable size, and technique like principal component analysis, as well as random projections, which is one of the techniques that I have used in my postgraduate studies, which I will also present to you some of the things I did because my work towards in dimension reduction area. And as a final topic, we will also talk about like how you may combine the outcomes of various different machine learning algorithms. Because if you see a winning algorithm, most of the time, combine multiple models to improve the accuracies. And in particularly machine learning area, we focus on various ways to improve the accuracy of these different algorithms. So therefore, we will dedicate our last topic on that one. So briefly, these are the topics that I actually plan to cover. Is there anything that you would like to add to this list? Or do you have any questions on what needs to be covered? Okay, so let's move on. Again, make use of chat sessions. You can always share me. You have in any concerns. How I plan to conduct the assessments, which is another important thing. So the continuous assessments, you will get about like 60%, which means like you will get some marks for the class participation, which means like I'm going to have time to time some quizzes, which directly account for about like 5%. Then the laboratory sessions as well as independent projects will be there, which accounts for about 35%. There'll be a mid-semester, mostly MCQ based, which accounts for about like 20%. So that's comes under continuous assessment. Then we will also have a finally end semester, which will be focused on understanding your theoretical understanding about the various different algorithms as well as applications. So those are the things that we normally evaluate in the end semester examination. So I hope now you got the idea of how this may deliver. So all this information is also I have uploaded the LMS. You can see the course structure and the topics and ILOs and aims. I have put it down in the LMS. And so once we finish the today's session, all the notes as well as video will be available for you to practice. Time to time, I will also provide you some additional readings for you, both in what is available in the net, some tutorials, and sometimes some research papers, which is focused on various different machine learning algorithms. Right. So that's about the assessment. Let's move to the next one there. So mainly, I'm going to use the Google Colab environment. One is, which is again popular in this particular area. The other one is ease of use, a collaborative tool that we can use. In case if you are thinking about apply this in offline, you can also check on what we call the Jupyter Lab. So those are the two things that I'm going to use, and mainly I will focus on Google Colab environment. Right. Any course, usually I recommend some text. So here are the texts I'm mainly referring for the module. And also I'm also recommending you, if you want to read more, there are plenty of resources are available. But a couple of things are more important for me at least, and for this particular course. This particular course is originally aligned with both data mining and machine learning, and you will notice that although we say machine learning, data mine also related to data mining also we will discuss things. So the main text that I'm actually using for this is data mining, practical machine learning tools and techniques. This particular book actually written, and also they have developed a tool called Weka, written originally in Java, so which was very popular. And before the Python comes out, as well as modules like scikit-learn comes out, right? But still, if you refer the book, it's nicely written book for elaborating how this machine learning algorithm works. And this is one of the primary texts I have used throughout my career, and most of my lecture notes actually based on this. So in case if you are interested in reading, so you can have a look. If you need more practical questions, a mainly theoretical one, I'm recommending the second one. Again, very similar to the very first one, but you have more practical problems. So in case if you are leaning towards like understanding the algorithms and trying to solve related problems, of course, you can refer the second one. But those who are want to, in the industry and those who want to build system, okay, I think we have to go with the Andrew next ones because he's one of the pioneers in this particular area from the very beginning. And he also contributed a lot. And also written a book on machine learning Yanni, which is freely available where you can refer. And he focused on practical implementations. That means if you planning to implement machine learning algorithms in practice, okay, I recommend you go through his recommendations given in as a book. It's about like 20 to 30 chapters, very small ones, where he focus on practical implementations and issues that you might be facing when you're implementing. So although the theory is important, the first two books, the third one I'm recommending those who wants to like focus on practical implementation. So those are the three textbooks I'm recommending for you for this module. Right. With that said, do you have any questions? Introduction. I will start with giving brief introduction to data mining, which is the originally this course is aligned, and then elaborate on the machine learning part. Right. Before we talk about the various, recent topics, so the data mining was very popular, like about around like 2 decades time, where we people, particularly in this particular area, were focused on extracting useful patterns from data. People were realizing the importance of data-driven decision making. So earlier, the top management or else people make decision based on the intuitions, based on the practical experience they have on their organizations. But things have changed. People realizing the importance of making decisions based on data. So data mining is an area where we focus on as a process. We are extracting useful information from data. So basically, the main problem that handle is how you can extract, strong patterns, because you can get some pattern. Nowadays you have tools, to implement machine learning within a couple of minutes or hours. Compared to early days, we spent like around 6 months to develop a machine learning solution. But the problem is, although we are getting something out of these, they are not very useful. They are not, when you implement, you might not get the expected outcome. So there are multiple reasons. One is, although you are getting some patterns, they are not very interesting, and that is not what you look for. And then the other one is they are not exact, right? They are simply wrong. You get something, but it's not, uh, uh, you don't get the correct answer that you're expecting, right? And the data is not in good quality. So those are the problems. So it was not an easy task, right? So in data mining provides you various machine learning algorithms which can be used to detect the patterns and the regularities in the data. So as I told you earlier, in simple terms, the machine learning, data mining was the process of discovering pattern. So the graph that you will see in the right-hand side is called Scripps DM, which is one of the data mining processes that people use to develop, data mining systems on those days, starting from understanding the data, because if you are given a problem to identify the patterns in the data, first of all, you need to have a good understanding about the business, right? For example, let's say I'm working in the education industry. I want to know how my students are performing in the module. I can collect data in various sources. For example, your Zoom interaction, your chats. The next one is your log information in LMS. Everything is recorded. But first of all, you need to understand the business, right? So as a teacher, I know what is happening. So similar to that, if you ask to implement a system for, let's say, medical domain, first you need to understand the medical domain. So that's what you will notice here. It starts with the business understanding. So you collaborate with the expert in that particular organization or the industry, understanding the business. Second one, you need to understand the data. So we'll discuss that today also. The data, you have numerical data, you have categorical data. So likewise, the next thing is you need to first identify the properties of the data, whether you have missing values, whether you have noises in the data. So you need to first understand the data part of it. So you start understand the business, then the data. Now, then once you understand it, you need to prepare the data. Then you make machine learning models, or nowadays we use the AI models. Then you have to evaluate them. You have to see how good they are. And if they are really good, then you can go for implementation. If it is not, maybe you have to start from the beginning. So that's what has happened in data mining area. So if I reiterate, simply you can think data mining as a process of discovering patterns in data. Right. Now, next we can talk about the machine learning. So before we talk about the machine learning, first of all, we need to understand what learning is. And right now, we are in a way of transferring the knowledge on machine learning from teacher to student. So that's one way to, make learning happens, right? Or else there are various sources that you can actually get the learn, and you can commit something to memory, right? So those are the learnings. If you take let's say, a small kid, how it, he or she learns with interacting the environment, right? With experience from the observation, right? So that's what is happening in the learning. But what is machine learning? Simply, we talk about learning from data. And remember the most important part, the focus area in machine learning. So remember, there are many areas like data mining, machine learning, data science, data engineering, and so on. So all these areas are different based on their focus. And in machine learning, focus is how we can improve the performance of this learning algorithm. Let's think about like this. Now, let's say we want to classify. Let's say we have a bunch of images as, let's say, cats and dogs. This is the toy problem we think about, like when it comes to image classification. So let's say we have a set of images where we want to build a system to separate them. Right. You will get some accuracy, right? If you apply a machine learning algorithm, you get some accuracy. Let's say you get 90%. Still, there's a 10% error which you want to improve it. So how do you improve? What are the ways? So this is the focus in machine learning, right? And remember that this is very important to understand. What you might see that, okay, all these different fields are doing the same. No, it's not like that. In particular machine learning, we focus on how we can improve the performance. When I say performance, it could be accuracy, and it could be the efficiency. So if you think accuracy, okay, maybe we will look at the ways of improving the precision of the algorithm. Then efficiency, how quickly you can get the result. So that also another way to improve this one. So make a note of this. Right. Now that we got some understanding about the data mining and machine learning, let me present you some definitions available in here. And although you might think the machine learning is not, it's not really new. It comes around 1959 when Arthur Samuel said uh, the machine learning is the field of study that gives computers the ability to learn, right? So one thing is ability to learn without being explicit program. Okay, you know that you can program, you can write a program to do something. But the difference in machine learning is you provide the data and then algorithm will give you the patterns or what needs to be learned about something. For example, if I go back to my original example of separating cats and dogs, we provide a set of images on cats and dogs, a label data, right? So that means we provide the data, meaning images, and then the outcome as cats and dogs. The system or machine learning model should be developed from data to separate out these two types of images, right? So we don't exactly say how it happens. We provide data and the algorithm will extract it, right? So that's what it says. Second one actually coming from one of the leading expert in this area in the very beginning in machine learning. We call Tom Mitchell, and his book was the very first machine learning book written on various different machine learning algorithms. He generalized what do you mean by machine learning, right? So I think I mentioned a couple of machine learning problems. We said supervised learning or classification. We said unsupervised learning, that means clustering. We said association learning, that means you try to extract the associations. So that means there are various different, learning problems. So he said, okay, well-posed learning problem. That's where he started. A computer program is said to learn from experience E. So he said the program, we can write a computer program and we can say that it's the program can learn from the experience, which means the data in our case. We provide the data and then program will learn. Respect to some task T. Okay, so there are various tasks, as I told you earlier. There are, classification problems. There are clustering problems. There are association learning problems, and so on. Okay, a computer program is said to learn from experience with respect to some task T. So you have a task, you have some data. So how do you measure the learning? Okay, let's continue. And some performance measure P if the performance on T as measured by P improves with experience. So simply what he puts is, so respect to a particular task, let's say classification, you have to have some performance measure. So let's say it's accuracy. So in our cat and dog example, right, we can measure how accurately the program can separate out cats and dogs. And what he said was, with the improving the experience, right, the P is also improves. That means when you have adding more data, right, the accuracy improves, which is what we have witnessing now, right? So this, he mentioned this is 1990, and later we have deep learning models where people realize that if you add more data, more accurate the model, right? Simply summarizing, machine learning, we can say it's investigate how computers can learn based on data, right? And as you can already discuss, there are ways that you can actually understand how much the particular algorithm learns from data. Right. I think you got some understanding about machine learning if you're very new to this. But if you look at machine learning techniques, in this particular subject, we talk about various different algorithms where you can extract what we call structural description. When I say structural description, it means like, let's say you have a classification problem. So when you have a classification problem, you have some data, and then you look for some, classification like cats and dogs. And how it happens is the structural descriptions, right? So these descriptions we can use to represent patterns. These patterns can be used to predict the outcome when you are given a new situation. These can be used to understand how this prediction derived. Okay, let me elaborate this one. So this is to say that this structural descriptions can be used to explain the prediction. Okay, let's think about some example. So let's take cancer classification problems. So in cancer classification problem, we can collect data about cancers, persons who's having a cancer and not. And then we can build a system to predict whether, given a new person, we can predict whether a person is having a cancer or not, right? So one is you use these to say whether the person is having a cancer or not. Second one is, sometimes it's very important that you understand why it happens, why that particular person is having a cancer. Let's take another example in banking domain. Let's say you apply for a loan, and let's say we are using machine learning to detect whether to provide the loan or whether to reject the loan. So now let's say you reject the loan, and then customer is furious, right, about the decision, and he might ask you why, and you need to explain the situation, why you have rejected the loan. So explanation of how you got the prediction is very, very important. So that's what the structural description can give you, right? And these machine learning techniques coming from various different brains, not just machine learning. It comes from the artificial intelligence, statistics, and even the research on databases. So it's actually a combination. Right, now let me show you like some examples and what we are going to do. And for this one, I'm taking this toy example. It's about playing a particular game. You can notice that there are some weather conditions as features. We have outlook, you have temperature, we have humidity, and we have windy. So these are like some of the weather conditions. And then this is what we are going to make the prediction. So based on these conditions, we are going to predict whether to play or not, right? So given this data set, what are the kind of patterns we can extract? So let me show you like some. Now, if you apply this to, decision rule extraction system, what do you mean by decision rule extraction? There are algorithms like Prism algorithm, which is very old, classification system. So what it does, the algorithm will give you a set of if-then rules. So this is the rule. This is the set of rules generated from this data. You have not hand-coded this. What happens is you provide the data set, and then the algorithm will give you this rule set, right? Next, we will learn an algorithm called decision tree. Provide that particular data set, you get a pattern like this, right? Decision tree pattern, right? You see a tree like a pattern, and this will be the output. This is the pattern you get from the data, right? How do you come up to this point? We'll discuss. Then associations. Now, what do you mean by associations? For example, associations are quite common nowadays. Let's think about something like this. You have a YouTube account and you go and watch videos in YouTube, what do you notice like your channels? So every time when you go, the videos comes in, are they random or are they, is there anything that you see in special when you visit a website like YouTube? What do you notice? Yes, it recommends, right? Recommends in the sense whenever you, let's say I'm interested in machine learning. And let's say if you're watching, videos related to machine learning, what happens next time when you visit? You see videos related to your interest, right? So how it comes? Okay, that's what we are going to discuss under associations, right? Let me give another example. You go to shopping mall and then you are interested in, purchasing some stuff. And once you record this information in the database, what we can do is we can see what customers purchase together. In old days, there was a paper in very early in machine learning. They were predicting that when uh, uh, when people purchase beers, they purchase diapers as well. I don't know how it relates, but you know you can see based on their buying pattern, you can make predictions. Okay, let me give you an example in my university experience. Like, for example, we have core courses and we have optional courses. Core courses are compulsory, but optional courses are not like that. And we can see uh, the relationships in what courses people, enroll together, right? So this based on the pattern. So that's what we call the associations. There was a question on what languages we are focusing on. I think I forgot to mention in this course, mainly we focus on Python programming. And I hope everybody is familiar with Python. Is it? Right. And another patterns, I'm actually presenting some of the what we call the structural descriptions, which means like some of the patterns that you can extract. So, for example, if it is not a classification, then sometimes some of the problems we may predict a particular value, which is comes from the simple regression functions. For example, given this data set, the idea is we can extract the linear regression function, right? Then we can discuss things like whether you need to include all the features, whether we can select only a couple of features. So those are the things that we need to understand. Right. Uh, Having said that, the patterns that we are looking and what kind of patterns that you may actually get. Let me discuss some examples, the application areas. So some of the things are very related to irrespective of a particular area that can be used. So that's what has happened to machine learning as well. You can identify a lot of applications in almost all the areas. So a couple of them are listed here in science, business, and web. Everywhere people actually using machine learning nowadays, starting from advertising, where to advertise, when to advertise. So all these can be implemented using machine learning algorithms. Customer modeling. So for example, we can focus on knowing your customers, we sometimes call customer profiles, because each of the customers, you have some profiles which you are interested in, and modeling is very, very important. So if I relate it to my experience, we do it for students as well. We create student profiles, right? One of the examples what we did, we can focus on couple of things when we are creating student profiles. So for example, we can focus on their demographic information, like before they enter the university, we can know their background information, their parent details, their performance on their O levels and A levels. That's one way to model it. Second one, their financial information. So for example, when people are paying for the degrees, right? We can also use that to model the students. Then we can also model their performance. For example, the courses that they are taking and what they're delivering. At the same time, the information we can extract from LMS. So that is another way to get the information. And maybe extracurricular activities, right? Sometimes students are, doing a lot of things in clubs, societies, as well as participating in various different activities. That also we can use to, create a student profile. So, which is very helpful for us. For example, we might be able to identify before, if there are failures, we can recognize using this. So similar to that, customer modeling is also important. Like, for example, customer churn, for example. People are switching products from one product to the other one. So if we can identify before it happens, that will be very, very useful, right? Then we will have a lot of application in nowadays in search engines and the bots use of machine learning, especially related to natural language processing and use of large language models. So we were able to pose the question in our own human-like language, human language, and you will answer in human-like language, which is very, very useful application that you can see. Right. Now, let me provide some of the problems and how machine learning actually handle those cases. So remember, I talk about loan processing. So the general loan processing is manual. I think most of the time in our system is also this happen manual, but things were getting, automated. Like the problem comes in when you have borderline cases. What do you mean by borderline? So, uh, so there are two things that they want to focus on. They are providing a loan. One is we want to improve the profits, where like the customers wants to pay at the same time. If there's a delay and if they're paying interest, that's how you make profits in loans. So borderline cases are very difficult, but they are the ones who are profitable as well, right? I hope you got the point. So when it comes loans, right, borderline cases very important. Make a decision whether you are going to provide the loan or not. At the same time, from the bank's perspective, these are the profitable ones, right? So usually if you do this in manual, it's 50% that, the prediction. But if you apply machine learning, you can actually improve the accuracies. Right. In this particular problem, when they implement it, they have selected around like 1,000 examples of borderline cases. They have collected around like 20 attributes, like each years with customer, current employer, years at current address, years with the bank, other credit card, and so on. And then they have showed in the system is they got about like 70% of accuracies in loan applications in borderline ones, which is very difficult. And if you use a human, the accuracy was around like 50%. Not only that, in this particular example, they have used what we call the decision rules, and then these rules can be used to explain the decision to the customers, which is another aspect that we have to think of. I think you might heard the word explainability. Uh, now that we can get very high accuracy with the deep learning algorithms, but one of the problems with deep learning, although your decision is accurate, there's no way we can figure it out why, right? Answering why question. And that's what we are trying to, make it more transparent, the decision making, which is one of the areas where people are focused on. Right. There's a question in the chat about the overfitting and what are the ways of overcoming the overfitting. Yes, of course, we'll talk about what is overfitting and how we can avoid overfitting when you're building systems. Yes. Right. Okay. Second example, can you guess what this is, or if you have seen this earlier? Any guesses?
So some kind of medical images.
Oh, definitely it's images. Not in medicine, actually. So this is like aerial images in sea. They were looking for oil patches when vessels going through the sea water. So there are some leaks, and they want to identify the leaks in images. So anyway, we are not expert, and it's very hard to identify any oil leaks, and this is quite even common for the expert as well. So in this particular application, where you get the aerial images to detect oil patches in seawater, so they say that it's very, very difficult to detect even with the expert. So they applied in machine learning models, right? And then in that particular case, nowadays we can actually use deep learning techniques where we can go into pixel level, and then we can extract features automatically. But in this particular one, actually quite old application where they have manually crafted the features, right? So in that particular case, you can notice that they collected the images and they have extract the attributes. So nowadays, people actually do this, especially if you have an expert, because sometimes you can incorporate the experts to get an idea like what things you look for, and you can extract attribute. In this particular example also, what they have done is they have extracted the images. They have applied image processing techniques to identify the size of the region, the shape, the area, and so on. And those attributes were fit into a machine learning model, right? And then they identified the improved accuracy compared to local experts, right? But there are some issues. Now, building machine learning models, like I told you, like deep neural networks will give you high accuracy, but the problem is you don't have enough data. Similar to that, many of our problems, we will have very few training data points. Yes. Let's talk about the cancer patients. I told you earlier as well. The problem is usually the number of cancer patients are less than 100, which is, although we have very sophisticated machine learning algorithm, you cannot apply them, right? So those are the issues that you have to understand, or we have to come up with solutions to, right? And data is unbalanced, right? Most of the time, problems like in this nature, you have, let's say you have positive examples and negative examples. Like, for example, in the cancer patient problem, the positive examples are cancer patients. You will have very less number of positive examples. So that's why we say it's unbalanced data, right? And then sometimes data duplications. In this particular example, so you are taking a bunch of pictures and then the same image you will see, right, in a batch, which means sometimes you have to, avoid duplicates. You might not get any extra added information having like more images from the same area, right? So you can notice that, so those are the things you need to, handle in, machine learning approach. Right. In time series, for example, in this particular example is from load forecasting. So especially in some of the countries, when they totally depend on, let's say, you generate electricity from water, because rains comes only period of time in the year. So you need to, generate electricity. Maybe you have to store, and then that process cost a lot. And, you have to balance between the demand and the requirement, right? Now, one example is when you produce more electricity, one way is you can, sell them to another country. But the problem is when you need it, maybe you have to purchase again from the other country. So you have to make a balance of this, right? So if you use, traditional techniques, it will be very, very difficult. And there are some seasonal variations that you need to focus on. So those are the aspects that you have to focus on when you're applying, problem like this, right? And then the problem is, in this particular case, how do you adjust for various different weather conditions, right? You can focus on when you're building a model, the base load, the periodicity, and the effects of holidays. We know that in the loads, for example, electricity, demand will increases when there are like holidays, which you will notice. Right. So as I told you earlier, most of the time when you have a problem like this nature, people focus on regional predictions, which means you look for more similar days. And then you focus on particular attributes like temperature, humidity, wind speed, and so on. And then you can actually build the model based on this, right? And in that way, you can improve the accuracy. So as you can see, so based on, problem, you might have to take different, approaches. There's no unique way or universal way to apply for all your problems, right? So that's why there's a huge demand in machine learning for the experts who can apply machine learning, because nowadays you can come up with the solutions, but different problems you have to handle it different ways, and different problems you have a different types of issues that you need to tackle, right? Which is not an easy task. Although there are now frameworks are built on for the common problems, there are many unique problems that you have to handle in machine learning, which needs a little bit of practice in the area. And solving various different types of problems is one way to grow yourself in the area of machine learning. Right. Now that we have learned about some of the applications, let's now focus on a little bit of ethics related to both data mining and machine learning. The problem now is, now we said in the beginning that we are interested in extracting patterns in data, which is what we do. but there are a lot of ethical issues when we apply these techniques, especially with the data, right? Now, for example, when you want to evaluate or when you want to learn something from your customers, usually for application, you are not allowed to use their uh, information to pinpoint the persons. For example, you will not get information like their names and maybe addresses, which normally is not recommended to use them, because that in that way, uh, it's not ethical that you use people's personal data to make some predictions. So most of the time we anonymize the data. Anonymize means like either we remove those columns like names and addresses and so on, or else we jumble the data. We will replace with something else. But still, anonymizing is very, very difficult, right? For example, in America, they used to say that if you have a zip code, which like postal code, date of birth, and your gender, they can pinpoint who that particular person is, right? So there are a lot of issues like this. So when you're doing or when you're building, applications, then you have to take very careful. You have to be very careful, especially those who are working the research. You have to be very careful because when you're publishing, they concern about this. They might ask you like whether you have get the ethical approval, because in university you have ethical review committees, and they should evaluate what data you are collecting and the use of fairness use of data. So when it comes to industry application, people can sue you. Like remember what happens in in some of the applications that people build, and people actually sue, saying that they have used their data. Like in ChatGPT, also, I think you might have read that some of the companies were file cases against them that they have used their data without the consent. So these things might pose problems if you build application, or if you use these things to publish the results in academia. So you have to be very careful. Often these application can use to discriminate people, like in banking application that we have discussed. If you use things like their gender, religion, and race is unethical. We consider unethical. You should not use property like that to distinguish. I hope those who works in the multinational companies, you know that in other countries, even you cannot ask person a gender. In Sri Lanka, it's not like that, but usually you can't ask that, or you can't, store that information in your database in HR departments. So this was explained in one of the software companies to me last time. But they say was like some of the things you cannot ask. Right? So similar to that, when you're using data to make predictions, you should not use like attributes like gender, religion, or race to make predictions, because this will discriminate people. Right? But this will be exceptional cases, like in medical domain, like getting their gender is useful in medical domain, right? So therefore, depend on the application, the same information may be ethical, maybe not ethical, like gender, as I said, right? Using in commercial application, use of gender is not ethical, while in medical domain, it might be ethical, because that actually help you to, find solutions, right? Then some of the places you have problematic information, like if you look at the area codes, districts, provinces in our case, that can correlate with the race as well, right? Which is not evident directly, but then that might be an issue. So you have to be very careful when you're building applications and when you're writing, publications. Okay, So that's the first part for today's session. So I think now we discuss about what machine learning is, machine learning applications, machine learning algorithms. In brief, we discuss about what kind of output you are expecting. And finally, we discuss the ethics. So from this point onward, for the remaining session for today, I'm going to focus on the basic types of learning available, as well as the key concepts, as well as how do you prepare the input, which means I want to discuss about how you may actually focus on attributes, missing values, and also like things like visualization. I hope you have already done these parts. So in our first exercise, I will give you some example you to think about applying this using Python. Right. Okay, going with the basic learning types, we are going to first start with the algorithms for classification. The idea is the algorithms are used to predict a particular class label we call a discrete label, like in weather. Then we have association learning. We will detect the association among the features. So depending on what features we are using, it could be item, it could be user as well. Let me elaborate. Now, YouTube videos. One way to look for association is we can identify similar users of the system. In YouTube platform, you can identify exact similar users based on what videos they are watching. And then we can detect, item, we call it. That means similar videos, right? So we can identify users who are similar. We can identify videos they are similar. Two different things, right? So which we will talk about this in association learning. Third one, we can focus on unsupervised learning, which means we look for groupings. Now, for example, if I go to a lecture in physical lecture session, and then I might notice how people are sit together. Usually you see a pattern, right? Maybe those who are friends will sit together. Those who are coming from same area may sit together. Maybe those who attend the same university may sit together. So you see some similar groupings. The key problem that we need to address is we need to figure it out. Okay, what defines those groups, which is very difficult. The last one, there are many other like reinforcement learning, which I am not going to discuss. I hope that part you have covered in AI, like Q learning and so on. So in neuroprediction, we will focus on extracting or predicting a particular value, right? So those are the four basic ones that we will focus in this module. Right, let me go elaborate more on this. For example, the example that I have showed you earlier is an example for classification, right? When we say classification, it's like you are trying to predict the actual outcome. So for example, in weather data, let's say the class is whether to play the game or not to play the game. So the outcome that we will expect is play or not play, right? And this is core class. Okay, that's about the problem. Then how do you say it's success, right? So we can say our system or our computer program can be successfully identified based on a new data, right? So that's what the term overfitting comes in. So most of the time what happens when we build machine learning algorithms, we'll get very good accuracy in the training, the data that we have. But whenever you test for the new data, you get very low accuracy, which is what we call the overfitting. That means when you build model, your model exactly represents your training data. If the model represent exactly your training data, then you will get a poor accuracy in test data. That is what we call overfitting. So you need to generalize the model. So what do you mean generalization? Okay, for example, you try best to get the high accuracy in the testing, right? So for that, we generalize the model, right? So that's about the classification. Association is, like as I already discussed, is looking for similar relations, like in features and the rows, like item, and use, and so on. So if you look at the supermarket basket analysis, which means if you want to look at buying patterns of the customers, you can identify what people buy together, like milk and cereal. So therefore, applications like this, you don't have one particular class. So usually if you perform association, normally we don't talk about a class here. Of course, we can use a class for the evaluation, but not for when you're looking for association. Right. In association, as I told you earlier, is very important and very useful nowadays. When you want to look for, as I told you earlier, similar users as well as similar items. We say use, user, and item. So in basic learning problem, if you look at it, it's just like in classification, we focus just only one class, like the play attribute. But here association, what it does, simply you look for any attribute, right? So then you can actually extract relations. There's a problem in this particular problem because you get more rules, more data, right? Compared to decisions, which is problematic. So therefore, we discuss how to minimize that. We are going to learn something called coverage and accuracy, which I will explain when we talk about related, algorithms. Right. Clustering one, we also discuss groupings, and there are applications or there are algorithms which can be used to identify the groups. And when we build the clustering applications, we don't have any labels as such. So therefore, we say it's unsupervised, right? But there's a problem in this particular area is we don't know whether it's a success or not. So therefore, success, we normally say that it's measured subjective because we can't exactly understand why it is happening. So that's mostly in manual. Once you identify the groupings, then you have to study the groups separately and try to understand that what are the properties of each of these groups. Right. Numerical prediction, as I told you earlier, you have a numerical quantity which we are going to make predictions, which is again very useful. Like especially in time series data, you will notice that especially financial domain, maybe you need to identify what is the predicted value, right? So that's what we call numerical predictions. Right. Now that we understood the 4 basic types that I'm going to cover, now I'm trying to explain the key concepts that you should be familiar with. And then we will discuss about how to prepare the data, the type of features that you will encounter, and how you may actually handle those features. Right. Now, any programming, any learning problem, we are trying to understand a particular concept. Let me explain from our dog and cat problem. So if you want to solve the cat and dog problem using a machine learning, you collect the image of cats images of dogs, and you build a system which separates cats and dogs. So what is the concept? The concept is we wanted to learn how to separate cats from dogs. So any ideas how machine learning will say recording? Okay, so we were discussing about the concept, and what I want to stress here is the concept is what we need to think to be learned when we provide the data. So, for example, in classification problem, what we are interested in providing the data as well as the labeled output. So we need to learn how it separates out, right? So the example we have looked at is, separating cats and dogs problem. And then what I said was like our system should automatically learn kind of features which will separate out, like fur patterns, the ear shape, and facial structure. And then we get it as a what we call the description. If it is a rule set, the rule set should contain that information, right? Not explicitly say, right? So I said like you can use deep learning, neural network to separate images separately. For if you look at the individual layers level, one layer might extract fur patterns, one layer might extract ear shape, right? So that's exactly what I want to highlight here as well. So success rate based on the new data points that we can use to say that how well the concept has been learned, right? For example, when I say 90% accuracy for separating cats and dogs, we can say that the concept of separating cats and dogs learn 90% accurately, right? So that's the idea of the concept. So based on the type of problem, we are trying to learn different things. So what is an example or the data point that we are going to use, right? So for example, in this particular case, if I take cat and dogs, so image of a cat or image of a dog will be an example. So that we are going to classify, right? Or associate or cluster, right? So then what features you are going to use, right? So images can be handled in multiple ways. You can use raw pixel values that can be done and it's direct. Or you can extract edges, the boundaries, the colors, the textures. Or you can extract explicit features from the images, right? That we have to decide like what attributes we are going to use for the representation. So that's why the representation is also important. Okay, let me ask a question again. So remember, this is the very important thing that we need to understand. Now, the data in a different form, like data we store in databases, if you look at like relational databases, they are normalized and they are in different tables. And then free text data is free. But you know that in all the machine learning algorithms that we use, we expect everything should be in a single matrix form, right? So the input to the machine learning, what we have discussed so far, we expect just one single matrix, one database, one table. Whereas our actual data in different ways, like we have normalized, we have tables separated, but when you want to analyze, we have to put them everything into a single file. So this is one thing we need to understand, right? So why it is important? So there are some things we are going to lose. For example, when you combine data into one single fat file. Right. Now, generating a single file or a fat file normally we call denormalization, assuming that your data is in multiple different ways. For example, nowadays we talk about multimodal data. What do you mean by multimodal? For example, particular problem, you can get data differently. You can take text data. You can have image data. You can have other various data to make predictions. Like most of the applications now uses multiple different types of data. In medical domain, let me give an example. In medical domain, let's look at like you are trying to predict a particular disease. So there are some information you get as a file, text file, maybe some diagnostic details, the measurements. Sometimes there are some images, X-rays, for example, is also available, another type. You also have some written text about the diagnosis, the reports coming from the doctors. It's another type of data. So everything should be put into one single form, right? Isn't it? To apply whatever the algorithm we have discussed in machine learning, right? So simply what we do is we join everything to make a single one, right? But the problem with this one is when you denormalize, you get fake patterns. So this is the first thing that you need to be very careful when you're combining the data. You are getting data from multiple different places and you are trying to put into a single fat file. And that might create some fake regulatories. So you have to be very careful, right? So there's a small example, which is I don't think it's that much relevant. But for example, if you have supply and supply address, and usually every time the supply is there, you will get the supply address, which is a direct pattern. These algorithms can spot and extract. And there's no real use of this. If supply predicts supply address, there's no real use for a problem that we are trying to address. Right. Okay. Now, given the concepts that given the data points, the next thing that we need to understand is all the attributes or the features, right? So what we say is for if you take a particular example, we will use two attributes to describe this. I told you about the images. Images can be represented as raw pixel values, or you can represent them as extracted information like shape of something and so on, right? So likewise, you can describe how you are going to represent the example, right? And the problem with that one is when you're extracting attributes, sometimes you will get variable attributes. For example, text data. If you use words as features, that's a simple representation. Text data, right? The simple representation is you can take words as features. So when you use words as features, not every word appears in all the documentation. So if you take documents as your example, let's say the first document, you have a set of words. Another document, a different set of words, right? So you can see attributes may vary, right? Some words are not relevant for the other documents. Then there are like dependencies. So some attribute depend on the other attribute. Now, for example, let's say you have whether you are going to have a spouse name or not based on whether you are married or not, right? Let's say you have data set. And whether the attribute is there or not is based on whether you are married or not to get the spouse name. Last one for today is you have different data types. Like you have nominal attributes, you have ordinal attributes, you have interval attributes, you have ratio attributes. So you need to know like various different attributes. Why? Because it depends. Depending on the type of data you have, you can extract various different types of patterns. So that's what you need to understand, right? I hope now you get an idea about the attributes that you are going to use, right? And the problems that you might face, right, when you are using attributes. Now that we talk about the attribute types here, let me elaborate a little bit more on these types and then finish for today. Right. First of all, nominal, or sometimes we call categorical. I use the nominal and categorical for the same. That means you have labels. You will have a unique set of labels. For example, in our weather data set, there was an attribute called Outlook, and Outlook had 3 different values. We had sunny, we have overcast, and we have rainy. So these are called nominal attributes, right? So when you say nominal, there's no order. For example, why I said that, it's very important. So you cannot compare like which one is better than the other one. There's no relationship between these 3 values, no ordering. And there's no distance as well. What do you mean by distance? So some algorithms like nearest neighbor, for example, we need to calculate the distances. So if you ask me like what is the distance between the sunny and overcast, okay, we cannot define a distance here. It's just 2 labels. Exactly. You can say it's a categorical attributes. Nominal means the same words that we normally use. Nominal and categorical are the same. You just have labels, right? What I'm trying to explain here is like if you take labels, in this particular case, there's no order, right? So there's no order among these labels, and there's no distance as well. You cannot quantify. You can quantify the difference between the sunny and the overcast, right? You can check whether the values are equal to each other. For example, if you take two examples, the value could be sunny. So you can check whether the values are equal to sunny or not. That's all. You can make the comparison. So that's about the nominal attributes. Next, ordinal quantities, which means you have labels, but you have an order. Remember temperature? Let's think about that. We have a temperature with labels, and the labels are something like hot, mild, and cool. So when you have hot, mild, and cool, you can specify order. So therefore, we normally call these types of attributes are ordinal quantities. So why it is this important? For example, we can come up with the rules like this. We can check whether the temperature is less than hot. When I say less than hot, there are 2 values, mild and cool, right? Since you can impose order here, right? But remember, very difficult to separate out with our previous one with the nominal, but there's an order, right? So you need to understand that one as well. Based on that, you can get inequalities when you extract patterns. Next one, you have intervals. So when you have interval quantities, right, you have order. At the same time, you can make or measure intervals. Like, for example, temperature, you can measure. And year, it's a measure. So, for example, you can talk about, getting the difference between 2 values. So, getting difference for temperature, getting difference for the years is meaningful. But if you think about the sum, it's not meaningful. Like you have 2 temperature values. Can you talk about something called summing up to temperatures? No. Summing up to years? No. Another point is 0 point is not defined, not like in numerical data, right? Although you have numbers, these are not considered as numerical data because you cannot talk about something called summing up here. It just you can take the differences. Therefore, we say these are interval quantities. The last one, and what we can is we can talk about, right, the ratio quantities. And there's a 0 point we can define, and you can talk about the distances. And when you talk about the ratio quantities, you can talk about summing up, you can talk about the product. So all the mathematical operations you can talk about, right, with the ratio quantities. Right, okay. Last slide for today's session. Although we discuss these different types, most of the time, right, we talk about nominal attributes as well as numerical attributes, right? Why I say that? You have labels or you have numbers. That's how normally most of the machine learning applications, machine learning implementations think about the attributes, although there are some orders, ordinal quantities are there. So therefore, we can actually boil down into two levels. We can talk about the nominal attributes, or we can talk about the numerical ones, right? So most of the time we assume that, but there are like special cases where you can focus on even the ordering ones, right? You can use that. Okay, so with that said, I'm going to conclude today's session. Just to summarize, what we discussed today is about the course and what I expect to, have the topics for this. I have also noted down some of the things which are not covered in other courses, which I will focus on more when I'm delivering. And we also covered the basic machine learning introductions, applications, ethical concerns, and finally, we were discussing about the inputs. So next session is basically focus on the supervised learning. We'll start looking at basic algorithms and also the extensions, right? When I say basic ones, we need to understand first the basic implementation of the algorithms and then advanced practical uses. Gayan asked like whether we will have to convert labels to numericals. Not all the time. It depends on what machine learning algorithm you use, right? Some algorithms supports for labels, so you don't have to convert into numbers, right? It depends on what machine learning algorithm you apply, right? And also what software system you are going to apply. So for example, some machine learning implementation, they request us to convert everything into numbers. Whereas some implementation, it supports both labels and numbers. So it depends on what implementations we use as well as what attribute type we have, right? Depending on that, we have to do. And sometimes you have to do the opposite. Sometimes you have to convert labels to numbers. Sometimes we have to convert numbers to labels, which I will discuss in coming sessions. Okay, good point. Because it labs and projects. Okay, there's a question on what labs I will conduct and the projects. Basically, project is like for a particular selected data set, you are going to build your own solution. Mainly, we can focus on a classification problem where you can select the data set and you are going to build your own version, which you are trying to get the best accuracy for that particular data set. For the labs, usually, what I do, once I cover the basic machine learning algorithm, we'll start off looking at basic implementations. And then we will also discuss about the data pre-processing, getting basic statistics, visualizations. And then the next part, we talk about how to evaluate. We'll discuss labs on how to compare multiple machine learning problems, then machine learning pipelines, and finally ensemble models, how you might combine multiple outputs of multiple machine learning outputs to improve the accuracy. So those are the kind of labs I'm planning. And there was a request to upload the lecture note. Yes, I will try my best to upload my notes. So what I could do is I will upload my old notes so that you can an idea about like what I'm going to have. But every time there are slide changes. So as soon as I finish my lecture, I will upload the updated note. I think that's fine with you. Okay, so nice to meeting you all, and let's finish for today, and hopefully we'll meet next week. In case if I cannot take the session, I will let you know through the LMS. Thank you guys. We'll meet next week then.